Welcome back, class. Go ahead and open up your books to page 431. We're doing Chapter 5, Lesson 7, 5.7 on page 431. Open up your books. Here we go. Here we're using distance in the coordinate plane. So we're going back to graphs and graphing with this one, but kind of using the Pythagorean theorem concepts to actually be able to find distance diagonally here, because usually on a grid we can find distance up and down by counting boxes pretty easily along with side to side, but anytime we have a diagonal line, things kind of change. And now that we know how to use the Pythagorean theorem, we can do that even better. So it says mountain biking. Evan was biking on a trail. A map on the trail is shown right here. His brother timed his ride from point A to point B. Here's point A, here's point B. So time this ride right there. It says, what do the blue and red lines on the graph represent? Well, the red line here, I'll just put red equals essentially like the actual distance he traveled or rode. So distance, I'll put distance biked. Okay. Then what do the blue lines here and here represent? Well, the blue equals I would put horizontal and vertical distance. Okay, so that's the vertical and horizontal distance. So because the blue here just represents the horizontal side to side, the blue there actually represents the vertical up and down. 2 says, what type of triangle is formed by the lines? Well, if we kind of see this, the blue lines here actually form a 90-degree angle right there in that corner. So basically what we have here is a right triangle. So we have our A and B sides, and then we have our C side right there. So what type of triangle is formed? You just put right triangle. Okay. It says, how can you find the length of AC and BC without counting the number of units? Well, counting would mean like, hey, I'm counting the boxes, but really there's a kind of a quicker way to do that. We know that BC, that one there, is our up and down. So BC, to find that one, I'm going to put a little arrow for finding that one. Basically, we can take our up and down number, which is the second one, our vertical. That's 9.5 and that's 4. So I can just do 9.5 minus 4, and that gets me 5.5. So I know my up and down vertical change is 5.5. Then here, I notice my side to side, that's a 3, that's a 7. So AC then is basically 7 minus 3, which is 4. So I know it's 4 units side to side, and then 5.5 units up and down. So fill in the boxes there accordingly. It says, write an equation using Pythagorean theorem that you can use to find the length AB. So now we're wanting to find that diagonal length AB right there. So first step is to write the Pythagorean theorem. A squared plus B squared equals C squared. Always write that down first. Now, what do I know? Well, let's look at this line here. Is this an A, B, or a C? It's an A or a B. Doesn't really matter which one. Usually if it's along the bottom, like a base, I'll put that as B. So my AC line is 4, so I'm going to write 4 squared equals. And then the other line here, the up and down, the BC, I found out that one's 5.5. So my A is 5.5 squared plus equals C squared. So if I find C, I'll have the diagonal distance right there that the bike actually traveled. Okay? All right, go ahead and turn the page. Now let's see a little bit more how this works on an actual grid. Well, here I have 2 points. Remember, points are always XY, XY, all right? So it says graph order pair 3, 0, and 7, -5. So that means forward 3, up and down nothing. That means forward 7, down 5. So we have a point, forward 3, up and down nothing from the origin. Then we have a forward 7, down 5. So we have these 2 points. If I connect the dot, it makes the diagonal. When we connect our dot here, our dots with these problems, that makes your C side, okay, your hypotenuse. Then you have to basically count the units or do math to determine your vertical change up and down and your horizontal change side to side. So we write our formula. Here the A is our side to side, so that's a 4-unit change. Our B up and down is a 5-unit change. So if we square those, we get 16, 25. That gets us 41 equals C squared. So how do we get rid of a squaring? We take a square root. So you take the square root of both and you get about 6.4. Notice the squiggly equal sign for when you approximate or round. So this diagonal is approximately 6.4 units. Notice it said units. Anytime there's not an actual unit like centimeters or meters and you're on a grid, you should put units or UN. Now let's actually do this one. So first we graph 1, 3. That means forward 1, up 3. I make my dot. Then here, negative 2, 4 means I go back 2, 1, 2, up 4. So I have those two. So I connect those with a straight line. How do I find that distance? Well, that line's not super straight. I'm going to use just dotted lines. So I want to make a right angle there, okay? When I do that, I have my right angle right here, okay? So my right angle right there, up and down, how many units is my change there? Well, my up and down change is just 1. What about my side-to-side change? Well, if I look here, I notice I move forward 1, 2, 3 units. So my side-to-side change is 3 units. So when I go to A squared plus B squared equals C squared, I just basically plug those in and solve. So I have 1 squared plus 3 squared equals C squared. 1 squared is 1. 3 squared, 3 times 3 is 9, equals C squared. Then we add, we get 10 equals C squared. Well, how do we get rid of squaring something? We square root. So that should get me just my C. So I'm going to take my calculator here. And I'm going to take the square root of 10. And that gets me 3.16. Now I'm going to round to the nearest tenth. So it's approximately squiggly equal sign here, 3.2. And there's no units there, so I put UN. So right here you should have 3.2 UN for units, okay? Now a good way to always check, your C side is always supposed to be the longest. So is 3.2 longer than 1 and 3? Yes. So I know my answer is fairly reasonable, okay? All right, class, we had a little bit of technical difficulty there for just a second. So I was basically just explaining the distance formula here, that it's basically just connected to the Pythagorean theorem. Your x's there are your x's squared are basically like your a squared, your y's squared are basically like your b's squared. You're adding them just like you do on Pythagorean theorem up here, and then you're taking the square root of those once you add them, as that right there shows. So let's take a look at an example using the distance formula. So here we have our distance formula. So it's, like I said, very similar to the Pythagorean theorem. Basically what it does is it just gets rid of the squaring C squared right away by making all of this square rooted, which mathematically still works pretty much the exact same way as before. So you kind of have two methods you can use here. That's all this problem is showing, is you have two methods. This person used the Pythagorean theorem for this particular problem here, and they did it like we did with the Pythagorean theorem, okay, like we just did on the previous example, and got about 4.6. This person here used the distance formula. Instead of finding that the distance was 3, or the change was 3, by kind of counting units, they here did the math, okay, for here. And so they had the x squared, or x2 minus x1. So it's negative 1.5 minus 1.5 was negative 3. The change in y was y2 minus y1. So that was negative 1.5 minus 2, and they got negative 3.5. They then squared both those numbers, just like we do in the Pythagorean theorem. Squared, you got negative times a negative is a positive. 3 times 3 is 9.
Teacher, sorry for the interruption. I have one quick announcement.
Hold on for Mr. Chase.
Need to meet in the gym for a picture for the yearbook. The first part of Bulldog Block. So if you're a DI student, please go to the gym for a quick picture when Bulldog Block starts. Thank you.
You can thank Mr. Chase for interrupting our video there. Remind him of that tomorrow. Then basically they did 3.5 squared. Negative times a negative is a positive. Squared it, added those, and then final step, just like with the Pythagorean theorem, is to take that number, square root it, and we'll get the same one. So now we're going to do an example with the distance formula here. All right. So it says Carmwell Field is located at 2.5 and 3.5, and the other field is at 1.5, 4.5 on a map. If each map unit is 0.1 mile, about how far apart are the fields? Okay. Well, here I'm going to use my distance formula. So my distance equals, I'm going to make my square root. Well, using my distance formula, I know it's going to be my x2 minus my x1. So my second x is 1.5 minus my first x, which is 2.5, squared, plus my second y, 4.5, minus my first y, 3.5, squared. So I take my calculator, and I have 1.5 minus 2.5, and you'll get negative 1. Don't forget it's squared. Plus 4.5 minus 3.5 is positive 1. Don't forget it's squared. D equals, bring everything down, and that's square rooted. Okay? Well, now I square. Negative 1 times negative 1 is 1. Plus 1 squared, 1 times 1 is 1. So my distance will equal 1 plus 1. Square rooted. So that's the square root of 2. My distance will equal the square root of 2. So I take the square root of 2, and I get that D, my distance, is approximately 1.4 units right there. Okay, so I get about 1.4 units. Here it's asking if each unit is 0.1 miles right there. It's going, okay, how far is this? Well, my distance in miles instead of units is approximately, that's a 0.1, so it's 0.14 m miles approximately. Okay. Last example right here talks about the same process, using that same distance formula to plug things in and solve. There's not really one for you to do there, so just look that over and come back tomorrow.